Good morning everyone, myself Sanjeev Kumar. Today in this lecture we are going to solve a simple problem on iron losses. We know that iron losses are two types, hysteresis losses and eddy current losses. But when the speed changes, these losses are also going to change. Otherwise these are constant losses at a particular current and speed. So let us calculate iron losses at different speeds. That means the losses are given, what is the required speed for this. So this is the question. The hysteresis and eddy current losses in DC motor running at 1000 rpm is 200 watts and 500 watts respectively. So hysteresis losses are 200 watts and eddy current losses are 500 watts. If the flux remains constant, at what speed the total iron losses will be 2400 watts? First case. And second case, 225 watts. That means the total losses are given. Individually hysteresis and eddy current losses are not given. The total losses is 2400 watts and total losses are 225 watts. At what speed these losses will occur? Okay, so generally these two losses, you can add these two, you will get 700, but we are getting 2400 means very high, so almost to 3 times. At what speed these losses will occur? And this will be almost 1/4 of here, 1/3 of here. So at what speed this motor is running? So for this we have to remember what is the hysteresis loss formula and what is the eddy current loss formula and what is the relations among them. Now the solution. So given data, you see the given data is a DC motor having hysteresis losses. I can indicate with the WH. So hysteresis losses 200 watts and eddy current losses I can indicate with the WE 500 watts. Okay, now these both losses are at speed, running at speed, so N is equal to 1000 rpm. Now these two losses are occurring at 1000 rpm. Then what is the total losses? Total iron losses at 1000 rpm. Now 200 plus 500, you may get 700 watts at 1000 rpm. Okay, if 700 watts at 1000 rpm, at what speed? That means at what speed WT, nothing but total losses. You can say that WT is total losses is equal to 2400 and is equal to 225 watts. Okay, now the corresponding speeds we have to find out. Now this is the data, and one more point is given: flux remains constant. Okay, flux is constant, so immediately the back EMF as well as your speed is going to be changes. Okay, now let us see how this solution will be evaluated if the hysteresis and eddy current losses are given. If you remember the hysteresis formula, we have WH is equal to H into B max square into V F into V, whereas eddy current losses are eta H into, this is B max X. Now B max square into F into T square into V. Now X is the 1.5 to 2.5, you can call it as a Stimmage exponent, and eta H is the Stimmage constant, eta E is the Stimmage constant, and B max square flux density square, and F is the frequency, T is the thickness, and V is the value. Now from this WH can be written as is proportional to frequency. Since image constant is dependent upon material and Bmax, the flux is constant, so Bmax is also constant, and volume of the material is also constant, and the flux. So what is this flux? The reversal of flux in the core, so that is going to be changes. It is dependent upon speed. If speed is higher, reversal will be higher. If speed is less, flux reversal will be less. So that's why I am keeping constant eta h, image constant, flux density Bmax, and volume of the material V also constant, so that I can written as WH is proportional to F. Similarly, eddy current losses are proportional to frequency square. Now what is eddy current losses? These losses are nothing but circulating currents rotating in the laminations. So these losses are also depending upon frequency and thickness, but anyhow thickness is fixed, the stampings are made, volume is also fixed, Bmax flux is constant, and eta E, the image constant, also fixed. Now WH is proportional to frequency and W is proportional to frequency square, but in DC the frequency term we are not using here, we write in terms of speed. So if speed is directly proportional to frequency, speed changes, frequency changes, so that we can write this frequency terms in terms of DC motor speeds. Okay, so frequency is directly proportional to speed, so replace F by N. So we can written as, therefore WH is proportional to frequency can be written as WH is proportional to speed. So that WH is equal to some constant A into N. This is the equation number 1. And from eddy current losses, WE is proportional to frequency square. So WE is proportional to N square. Since F is proportional to N, you can also write here, since F is proportional to N, so WE is equal to B into N square. So this B is one more constant. Now hysteresis losses can be written in terms of A into N. So A may be constant, so this value calculated you can find out the hysteresis losses, and W is the B into N square. So this is a square term, speed square term, so you can calculate the A and B value, so that we can find out hysteresis and iron losses at any speed. Okay, so the first equation is A into N and second equation is B into N square. Now we will calculate what is the actual value of A and B, so that we can calculate the hysteresis and eddy current losses at different speeds. Okay, now I will take up the data. So not that much data is available, only losses at one speed is given. Okay, we have, so WH is proportional, so WH is equal to A into N. That means at speed 1000 rpm, nothing but if N is equal to 1000 rpm. If N is equal to 1000 rpm, what is the WH value? It is given nothing but 200 watts. Now substitute N and WH value here, substituting WH and N value. So WH is equal to 200 and A into N is equal to 1000 rpm. So what is the A value you are getting here? 200 by 1000, it is nothing but 0.2. So A is equal to 0.2. Now the value of A is equal to 0.2. So that you can calculate hysteresis losses at any speed. Just you replace N by different speeds, you will get the hysteresis losses at different speed. Similarly, we find out the B value also, so that we can calculate eddy current losses at different speeds. Now we have We is equal to B into n square. At n is equal to 1000 rpm, We is equal to 500 watts. Okay, now substitute substitute n and W value. Okay, so what you will get? We substitute We and n value. So W is equal to 500 and B value we don't know, we have to evaluate, and n is equal to 1000 rpm, but it is a square term. Okay, now you see what is the B value. B is equal to 500 by 1000 into 1000. Now you can see here 2020, so you will get almost 4 zeros. So that B is equal to 5 into 10 to the power of minus 4, nothing but 0.005. We calculated A and B values. Now we have to calculate if total losses are 2400 watts, how many hysteresis losses are there and how many eddy current losses are there. So case 1, if you consider, if total losses WT is equal to 2400 watts. So what is WT? WT is nothing but WH plus WE, hysteresis losses plus eddy current losses. But we know the relation between hysteresis losses and speeds. Okay, so we have WH is proportional to N, so that WH is equal to A into N, and W is proportional to N square, so that W is equal to B into N square. So that WT is equal to AN plus BN square. So nothing but 2400 watts equal to A into AN plus BN square. But we know the values of A and B. So if we substitute A and B values, we will get the solution for N. So let us see. Substituting A and B values. Substituting A and B values. So A is equal to 0. So 2400 is equal to A equal to 0.2 into N plus B. We know the B value is nothing but 0.005 multiplied by N square. And if you observe this equation carefully, so this is nothing but a quadratic equation. So one square term is there and one term is there and again one constant is there. So looks like x square plus bx plus c. So let us rearrange this equation. So rearranging equation 0.005 n square plus 0.2 into n minus 2400 equal to 0. Now this is the equation. If you observe carefully, this is the quadratic equation. Now we have to find out n value for this. Okay. So dividing both sides by this term, which is nothing but 0.005. So what you will get dividing this n square plus 0.2 by 0.005 to n minus 2400 divided by 0.005 equal to 0. So 0 by 0.005 it will be 0. Now if you calculate this term 0.2, so n square plus 0.2 into 10 power 4 by 5 minus, if you take out this 2400 by 5 into 10 power 4 equal to 0. So just I am substituting 5 into 10 to the power of minus 4 instead of 0.005. If you take this n square plus 200 into 100 by 5 minus, so this term will be 480 into 10 power 4 z. Now 5 1 and 4 times of this equation. So how much you are going to get here? So this will be the 10 power 4 term. So if you multiply with this, you will get 20. So this equation is going to be now n square plus 400 into n minus, this is 4800. So you can see 48 into 10 power 5. Now for this, if you calculate the roots, that means solving for n, you will get, so the formula we know for quadratic equation, minus b plus r minus, so minus b is nothing but 400 plus r minus, so b square is nothing but 400 square minus 4 into a. So what is the a value? 1, and what is the c value? Minus term is there, so you have to substitute carefully minus term for this. Now divided by 2 into 1, so this will be the n value. Now further you calculate this value, so you may get minus 400 plus or minus, so 400 square is 16 into 10 to the power of 4. You will multiply this 48 into 4, you may get 192, and it is positive, minus into minus plus, so 192 into 10 power 5. Now you can see here this term, if you see this term very carefully, this is 2, so n equal to minus 400 plus or minus 1.6 into 10 power 5 plus 192 into 10 power 5 under root divided by 2, so you will get minus 400 plus or minus, so 19 point, if you multiply this by 193.6 into 10 to the power of 5 divided by 2, so this term being 400 plus or minus, so 1936 and 10 power 4, nothing but 000 divided by 2. Now 1936 10 power 4 is nothing but 10 power square, so 1936 is nothing but 44 square. So if you substitute the value, now calculating the root for 1936, you will get n equal to minus 400 plus or minus 4400 divided by 2. Now taking positive term, so n equal to minus 400 plus 4400 divided by 2, so n equal to 4000 by 2, which is nothing but 2000. So n value will be 2000 rpm. Now if n value is 2000 rpm for 2400 watts, so what will be the iron losses, and what will be the hysteresis losses, and what will be the eddy current losses, we will calculate. So this is the simple quadratic equation solution. Now the first, you can see, if n equal to 2000 rpm, so WH is equal to A into n. Now A value is 0.2 multiplied by 2000, so you may get 400 watts. Now this is WH, if n equal to 2000 rpm. So similarly for we is equal to b into n square. Now you substitute b and n value. W is equal to b is nothing but 5 into 10 power minus 4 or 0.0005, and n is nothing but 2000 squared. Now 5 into 10 power minus 4, so 2000 to 4, and this is 10 power 6, it is nothing but 10 power 3 whole square. You can see here, so 6 power 10 power 6 minus 4, so it will be 2, and 20 into 10 square, so you may get 2000 watts. Now this will be the eddy current losses, and this will be the hysteresis losses. 2000 plus 400, 2400 for the first case. Now like this, similarly we can calculate the second case where the losses are 225 watts. You can also observe the losses are increased if the total losses are 700 watts at 1000 rpm. If speed increases to 200 rpm, so these two losses at n is equal to 2000 rpm. Now you can see here speed is doubled, so hysteresis losses are doubled, 200 into 2 400, but eddy current losses you can see here 500 and it increases to 2000, means 4 times. So hysteresis losses are doubled, but eddy current losses are 4 times increases. So like that we can calculate the second case, that is if the total losses are 225 watts. Now we have to calculate if the total losses are 225 watts, how many hysteresis losses are there and how many eddy current losses are there and what speed the motor is going to be running. So we know A is equal to 0.2 and B is equal to 0.005, is nothing but 5 into 10 to the power of minus 4. Now if total iron losses 225 watts, nothing but Wt is equal to 225 watts, but we know Wt is equal to Wh plus We, which is equal to 225 watts, but Wh is proportional to N, so that Wh is equal to A into N, and W is proportional to N square, so W is equal to B into N square. Now, hysteresis losses are directly proportional to speed and eddy current losses are directly proportional to square of the speed. Now we know AB value and we will having the total losses. Okay, so for total losses, WH plus W is equal to WT. So WT is equal to A into N plus B into N square. Now substituting A, B and WT. So WT is nothing but 225. The total losses are 225 and A. So what is the value of A? 0.2 into N plus what is the B value? B equal to 0.0005 into N square. Now again you see this equation, it looks like a quadratic equation, so we can solve this equation. So just rearrange these terms. 0.005 into n square plus 0.2 into n minus 225 equal to 0. Now this is a perfect quadratic equation. Now we will calculate the roots, but simply you make that means dividing both sides 0.005. Now what you will get if you divide both sides? So n square plus 0.2 by, I will write 5 into 10 power minus 4 minus 225 by 5 into 10 power minus 4 equal to 0. Now n square plus, it is nothing but 10 power 4 into 0.2 by 5 minus 225 into 10 power 4 by 5 is equal to 0. Now you can see here 10 power 4 into 2, so 2000, it is nothing but n square plus 2000 by 5, 4 n is there, 400 n minus, so 5145 into 10 to the power of 4 equal to 0. Now A is 1, B is equal to 400 and C equal to 45 into 10 power 10 to the power of 4. Now we will find out the roots, that means the value of n, by using quadratic equation formula. So that is, now what is the formula for quadratic equation? So here it is n. Now b square, so minus of minus b plus or minus b square minus 4ac. So what is b square? 400 square minus 4 into a is equal to 1, and c, so it is a negative term, minus 45 into 10 power, so 10 power 4 divided by 2 into 1. Okay, so can multiply this. Now minus 400 plus or minus, so 4 4 16 and it is equal to 10 to the power of 4, 100 minus minus into minus plus 4 into 45, it is equal to 180 into 10 to the power of 4 divided by 2. Now 16 plus 180, 196. So 400 plus or minus the root of 196 into 10 to the power of 4 divided by 2. So we know that 196 is nothing but 14 square and 10 power 4 is nothing but 10 square. So we will get minus 400 plus or minus 14 and 0 divided by 2. Minus 400 plus or minus 1400 by 2. So the first term is negative. Now we take the positive value, that means positive sign. Okay, so taking positive sign. Now n is equal to minus 400 plus 1400 divided by 2. Now it is nothing but 1000 by 2. So which is equal to 500 RPM. Now the motor is running with 500 RPM. Now if the motor is running with 500 RPM, what is the hysteresis losses and what is the eddy current losses? You can find out from the AN and BN square. So we'll calculate hysteresis losses. Hysteresis losses at 500 RPM given by, so hysteresis loss is equal to A into N, nothing but 0.2 into 500. So you will get 100 watts, which is equal to W. WH is equal to 100 watts. Now how much eddy current losses? So we can see, so WE is equal to B into N square. So B is equal to 0.0005 into N equal to 500. So it is a square term you can get. So this is 5 into 10 power minus 4 and 25 into 10 power 4. 500 can be written as, so 10 power 4 and we will get 125 watts. So this is eddy current losses and this is hysteresis losses. If you add these two, you will get 225 watts. Now this will be the case when both losses will calculated depending upon A and B values. Now you can check out for different speeds how the losses are going to be changed. You can see if the RPM is 1000 RPM, the losses are 200 plus 500. Now if the speed is 200 RPM, now the losses are 200 plus 400 plus 2000. And if the RPM is 500, now the losses are 100 plus 125. You can see here, if speed is doubled, hysteresis losses are doubled, but the eddy current losses are increased by 4 times. And if the speed is going to the half value, then the losses will be, hysteresis losses will be half value, but eddy current losses are decreased by 1/4 times. So eddy current losses changes with respect to the speed square times. So that's why these losses are majorly affected if the speed changes.